Okay, so basically what number 3 is asking is it wants us to get the what was it? Yeah, okay. It wants us to get the net force on particle 3, and the way you do that is we use Coulomb's law to figure out what that net force is going to be. So, because there are two particles that are exerting force onto Q3, particle 3, we have to basically add them as vectors. So the way we do that is we're going to use Coulomb's law to calculate the x and y component of the force exerted by each particle onto particle 3, and then add those components together, and that would be the net force exerted on particle 3. Now, all of this entire problem takes place exclusively on the x-axis, which means that the net force in the y direction is just going to be 0, which means we don't have to do anything for that. So instead, we're just going to calculate the force in the x direction, which means we can just calculate the force normally. So, okay, focus, thank you. So I drew it out. I drew out the problem. This is Q1, this is Q3, and this is Q2. Now, something you want to keep in mind is particles with opposite charges are going to attract each other, and particles with positive charges are going to repel each other. Or, sorry, particles with the same charges are going to repel each other, or like the same, like if two negative charges are going to repel each other, and two positive charges are going to repel each other. So if they have the same sign, they're going to repel. If they have opposite signs, are going to attract. With that said, that means that Q1 is going to pull Q3 to the left, and because it's on when it's going to the left, that means it's going in the negative direction. When it's going in the right, it means it's going in the positive direction. And then Q2 and Q3 are both positive, which means Q2 is going to push -3 also in the left, which means that's also going to be negative. So they're both going to push it into the left, which is the negative direction. So with that in mind, let's do Coulomb's law, which is F net. Let's just do Coulomb's law for the charge of particle 1 on particle, or the force of particle 1 on particle 3. So F net is going to be F net of please wake up. Thank you. All right. Let's write, yeah, okay. F Q1 on 3 is going to be, let's see, K times Q1 times Q3 over R squared, which is just the distance between the two particles. So, R13 squared, I guess I should put. So, first, let's calculate R squared, because we don't know that distance yet. The distance between Q1 and Q3, you can just calculate by doing, we have, well, it's negative 1.685 and negative 1.21. So if we just did 1.685 minus 1.21, because we want the absolute value of the distance. 1.685 minus 1.21, 0.75 meters. So the distance between 1 and 3 is going to be 0.475 meters. And so now we can just plug in numbers. So F net 13 is going to be K times Q1, which we calculated, or which it gives us is so don't worry about signs when you're finding the magnitude. We'll just figure out the signs after we find the number. So just put 16.5 nanocoulombs, and because it wants us to use coulombs, that's going to be 16.5 times 10 to the negative 9th coulombs. Because you want to convert nanocoulombs into coulombs. Nano is to the negative 9th, so that's what that's going to mean. And then we have Q3, it's going to be 53.5 times 10 to the negative 9th coulombs, all over, this is annoying, okay, all over r squared, which is 0.475 meters squared. And then K, I shouldn't have written it as K. K, I'm gonna write it on this side now. Actually, I'll write what the constant equals here, but hang on, okay. K is equal to 9 times 10 to the 9th, and then the unit you don't really have to write, but this is how the units are going to cancel out here. The unit is going to be newtons times meters squared all over coulomb squared, which if you see, coulomb times coulomb here is going to be coulomb squared is a meter squared down here, so that would cancel out this, that would cancel out this, that would just give newtons, which is the unit for force. But anyway, so let's multiply it by K. That's 3 lines, wow. Alright, 9 times 10 to the 9th Newton meters squared over coulomb squared. And so now, just multiply the top together, and then divide by the bottom. So, 16.5 negative 9 times 53.5 e negative 9 times 9 e 9, and it's a positive 9, by the way, for K, just so you remember. And then divide it by r squared, 0.475 squared, and so that means that this is the force of part of Q1 on Q3. F13 is going to be 3.52 times 10 to the negative 5th newtons. And then another thing you want to keep in mind is normally when you're trying to calculate, because remember we're adding, we have to find the force of Q2 and Q3 now, and then we'd have to add them as vectors, which would mean that this is the magnitude of the vector, and we'd have to separate that into x and y components in order to add it to the Q2 on 3 vector. But because because this problem takes place entirely on the x-axis, it means that the y component of the vector is going to be 0, which means that the x component is going to be the entire vector, so 3.52 times 10 to the 5th newtons, which I guess in vector notation would be 3.52 times 10 to the negative 5th I plus 0j, and then newtons. And then one more thing, now that we found the magnitude, you have to remember that that's an absolute value. We have to figure out if it's pulling it in the positive or negative direction, which we already decided, because this is negative and this is positive. It means they're going to attract each other, which means Q3 is going to go to the left, which is negative. So that means that this value here is going to be negative 3.52 times 10 to the negative 5th. So now we have the force of Q1 on Q3. Now we need the force of Q2 on Q3. So here. Alright, so I did the formula for the force of Q2 on Q3. We have K times Q2 times Q3 over R squared. R, which we calculated by looking at, we have Q2 right here is at the, it says it's at the origin, so it's at 0, and then Q3 is at negative 1.21, which means that the distance is just going to be 1.21 minus 0, it's 1.21. And then this is Q2, this is Q3, and then it's divided by R squared. So then just plug it into the calculator, which I'm going to do off camera. Okay, so now we have, what you'd get is 1.26 times 10 to the negative 5th newtons, and then you have to remember we said that Q2 is positive, Q3 is also positive, which means that they're going to repel each other, which means that Q2 is going to push Q3 away from it so that means it's going to push it to the left, which is the negative direction, which means that it's going to be negative 1.26 times 10 to the negative fifth. And then to get so now we have the net force of now we have the force of Q2 on Q3, and we have the force of Q1 on Q3. So what we do in order to get the net force on Q3 in this system is we just add them together. Now I want to say, because it's entirely in the x direction, or this problem takes place entirely on the x-axis, we can just add the numbers that we got together. Normally you have to separate it in component form. If there was any if either of the force vectors of Q2 on Q3 or Q1 on Q3 had anything in the y direction, you would have to separate basically this number we got here. This would be the net force of 2 on 3. You'd have to separate it into an x and y component, and then you'd have to add it to the x and y components of Q1 on Q3, and then that would be your answer. But because we don't have to do that, let's just add F13 here, and I'm gonna do this in component form just so you can see it, but you obviously don't have to. You just have to do the x. You don't have to do the y because it's 0 for both. But all right, let's do negative, and it was 3.52. 3.52 I. Oh, sorry, no, I forgot about the 10 to the negative fifth. Times 10 to the negative fifth I plus 0 J newtons, and then we just add these together, which you should get negative 4.78 times 10 to the negative fifth newtons, and that would be your final answer. This would be I and then plus 0 J, and then this is your final answer right here. It's just ignore the I, but yeah, this is your final answer.